Hello everyone and welcome back to my channel. Today we want to look at some interesting math topics that we can actually use. Okay, so with this topic, the reason why I want us to look at this topic is that it actually covers areas where students find the most difficult to solve when it presents in exams. That's one reason why I want us to look at it. Also, solving this kind of questions will help us discuss various concepts that is related to math or that can ever be present or presented during your examination. It could be any form of examination: BECE, WASSCE, JEE, IIT, SAT, etc. Okay, so without wasting time, let me just quickly use this opportunity to say thank you for following me from the time I began. I think it's been almost 3 months now. I think we've come a long way. It's actually a good thing that you're able to follow suit. Okay, so without wasting time, we'll start now. When we look at the question on the board, let me just choose a marker. I think I'll go with the yellow. Let me change the colors a bit. This green. Fine. Okay, so when we look at what we have on the board, basically this they are basically triangles that are joined together. Okay, so now with this one, there are two ways to look at this. Okay, with this one, when it is flipped over to look like let me see and get the shape that I want to talk about. Okay, so when it's flipped over, basically this is how it's going to look like. So it means that the 90 degrees is here, and then diagonal 2 is here, and then we will have the x here, and then the 5 will be here. Okay, and then we have 10 here. Okay, and so basically this is where x is supposed to be. Let me clean that and then draw that again. Okay, so basically this is how the x, or where the x will be. Okay, but we are not going to use, when you look at this closely, then it should be able to tell this was 15. This should tell you that this is a trapezium. Okay, this is a trapezium, but we are not going to use the concept of trapezium to solve it. Okay, we are not going to use the concept of trapezium to solve it. We are going to use the knowledge of right angle triangles to solve. Okay, we're going to use the knowledge of right angle triangles to solve this. And I believe using the knowledge of right angle triangles is going to help us actually build knowledge of the right angle triangle concept. Okay, it's going to help us build knowledge of the right angle triangle concept. Okay, so I want to pause for a few minutes. I want you to analyze this and then tell me how best you can solve it, because when you look at it, can you solve or can you find x and y? Just analyze it a bit. I just want to give you the opportunity to think a bit out of the box to see. Okay, less than 30 seconds. Just analyze the question. Okay, so 30 seconds. We are waiting. Okay, so I think the 30 seconds is up, so we'll just spring into action and then solve this quickly. Okay, we'll spring into action and then solve this quickly. So solving this basically will mean that we need to find two things. We need to find x and then we need to find p. Okay, So first of all, we'll try and concentrate on finding x. Okay, we'll concentrate on finding x. So I'm going to clean this thing that I have illustrated here because I need the room to do the calculations. Okay, so now I'm going to be writing on the diagram we have there. I'll be writing on the diagram we have there. Okay, so writing on the diagram, the first thing we can do by solving. Okay, this is the most important indication of what we need to do. This box here indicates that this line is perpendicular. So once this line is perpendicular, it means that this one will also be perpendicular, because at the end of the day, if I should put broken lines here, then it basically means that we are dealing with what? A rectangle. So dealing with a rectangle, basically, once you have one perpendicular side, it means all the sides are perpendicular to each other. Okay, so if this place is 90 degrees, this place will also be 90, this will be 90, and this will be 90, and the total obviously is going to be 360, and 360 is actually the total or the sum of angles in a quadrilateral. Quadrilateral basically is what? A shape with four sides. Okay, a shape with four sides is a quadrilateral, and a rectangle has four sides. So basically, a rectangle is a quadrilateral. So without wasting time, once I've established that, then I can easily go ahead to find x. Okay, by basically separating the triangles. Okay, the only issue we might have will be this side of the triangle and finding p. Okay, so because of this broken lines that I have introduced, okay, because of this broken lines I have introduced, it basically means that what? To find p, we would have to consider this third triangle that I have drawn here. Okay, so in a nutshell, if I should draw each of the triangles I have, the first one should look like this. Okay, so the first one, this is how the first one looks like, and then we have this perpendicular. So they are asking us to find x. This is where x is, and then let me clean that. It didn't come out. Okay, so that's where x is, and then we have 15 here, 15 centimeters, and then we have 10 centimeters here. Okay, so having that, basically to find x becomes easy, because we are going to use what we call the Pythagoras theorem, where it says that. So let me quickly explain Pythagoras theorem for you. So Pythagoras theorem, it says that when you have a right angle triangle, and I believe this one is an example of a right angle triangle. Okay, when you have a right angle triangle, this is square, a square, and then b square. We are not going to discuss how to develop the right angle triangle, because that's not the purpose of this lesson. But if you've been following me for some time, by now you should know that I've actually discussed this. Okay, so you can look through the videos that I have done to see if you can see a lesson like this. But then again, I'll try and see if I can do a separate lesson that will be mainly focused on this particular kind of theorem. Okay, so having this, it is this side that we want, right? It is a that we want, because technically, if I should flip this over to look like this, then it means the a is the same as what? The x. Okay, so technically it's the a that we will be looking for in this formula. So let's quickly make a the subject in this formula, and then making a the subject, it basically means that this b is going to come this way to what? Subtract, because it is adding over here. So in order to do so, it becomes let me use the blue, becomes c squared minus what? B squared equals a squared. And then if I should write it, so it becomes a squared equals c squared minus b squared. And then because we want only a, which represents x in the diagram below, which represents x in the diagram below, we need to get rid of the square. Okay, so getting rid of the square basically means that we need to apply a square root. So I'll apply square root on both sides, and then the square root will cancel the square. So once I've done that, then it means that we'll have a to be equal to root of what? C squared minus b squared. Okay, c squared minus b squared. So basically, this is the formula I'm going to be using to find the value of what? This x. So without wasting time, we can now establish that c is equal to 15 centimeters. It's very important for you to write this. So you can say where c equals 15 centimeters, and then B equal 10 centimeters. Okay, B equal 10 centimeters. Once we've established this, then we can go ahead, take the formula and slot in our variables. So this becomes 15 squared minus what? 10 squared. Okay, 15 squared means 15 times 15. So let's do that calculation. 15 times 15, what would that give us? In the chat section, if someone can get us the calculation for 15 times 15, let me just use this opportunity to make the lesson interactive. So in the chat section, 15 times 15 waiting. Yes, 225. Thank you very much, Elom. So it means that 15 times 15 is 225, and then this is 100. Okay, so when we do the subtraction, what will be the answer? In the chat section, what will be the answer? Okay, so 125. And then can we have the square root of 125? Is 125 a perfect square? I'm waiting. Is 125 a perfect square? What do I mean by a perfect square? Can we have two numbers that when we multiply, it will give us 125? Okay, so it means that we'll just leave it as root of what? 125. Okay, so it means the value of x is actually root of what? 125. So let me write it here. Root of what? 125. Please do not just write 125. Root of 125 is different from what? 125. Okay, assuming it was 25, then it basically means that at the end of the day it becomes 5, because the square root of what? 25 will be what? 5. Okay, so once we've done this, we've established this, we've found what? X or A. It is going to help us find the other part of the triangle. Okay, so I'm going to clean this side of the board. Okay, because I think we need the diagram, so I don't want to scroll up. So I'm going to clean this side of the board, and then we are going to manage. Okay, so with that out of the way, now we want to concentrate on finding P. Okay, and then to find P, I would have to do some form of drawing. So I want to draw the P triangle, the triangle that has the P. Okay, so basically that is how it looks like. It might not be perfect, but I think we should manage. And then the 15 is here, and then we have 5 centimeters here. Okay, and then we have P here. And remember I said that because this is a right angle triangle, what we need to do is that, and then because of this 90 degrees, it shows that all the lines are perpendicular. So it means that if you want to complete the drawing for the right angle triangle, then it will end up, sorry, this is not straight, but yeah, you should be able to see. Let me just clean it. Okay, so this is going to waste time, so let me just clean everything, and then I have to wait for the software. The software is a bit slow, sorry about that. Okay, yeah, finally it's gone. Thank you. Oh, come on. Okay, so I have this back. So I'm just going to use a different marker to do the indication. Okay, I'm going to use a different marker to do the indication. So it means that if you should adjust that side, you should also get this. And then remember all the angles in the rectangle is what? Perpendicular. So it means that this place will also be perpendicular. At the end of the day, it basically means that this small triangle that I've drawn here is a right angle triangle, so we can actually separate it. And then when we separate that right angle triangle to look like this, this is how it's going to look like. It's not that big. Okay, to look like this. But when you look at it closely, this is where P is, and then P now ends up here. But we need to find the sides of this. Okay, to find the side of this, if they are saying that from this side, let me use a different marker. Let me use yellow. So they are saying that from this side to this side is 10 centimeters, okay? And then the same measurement should run from this side of the image to this side of the image. So it means that from this side to this side should also be 10 centimeters because we are actually dealing with what? Rectangle, okay? So once we have that, if it's 10 centimeters and we have 5 centimeters already, it means that this is also supposed to be 5 so that it will match up with the upper measurement, okay? So basically this is also 5, so we can confidently say that this place is 5 centimeters. So this place I can write what? 5 centimeters. And then it's left with this side for us to find. Since it is a rectangle, this place is x, and then this place will also obviously be x because these two sides are equal, these two sides are equal. And then we've been able to find the value of x, which is this. So it means that this place is going to be root of what? 125 centimeters. Okay, so we are going to use the same concept we used in solving for the x. Okay, we are going to use the same concept we used in solving for the x to solve for the p. Okay, and then with this time around, if I should draw a right angle triangle, let me see if I can draw a right angle triangle nicely. Okay, it doesn't look like a right angle triangle. Let me clean it. So if I should draw a right angle triangle, something like this, yes, we will agree that once it has this box in there, this is c squared, this is a squared, and then this is b squared, okay? So, and then the formula will imply that it's going to be c squared equals what? A squared plus what? B squared. And then it is c we want. P looks like c, okay? P looks like c. Let me write my c well. So P looks like what? C, okay? So basically it is C that we need to find in this particular question, okay? So quickly, to find C basically means that we need to get rid of this square. So to do so, we have to apply square root on what? Both sides of the equation. And then you see, when you're applying the square root, it should cover the a squared b squared, because whatever you do to one side of the equation, you need to do to the other side of the equation. So you can't apply a square root to only the a squared. It should also affect the b squared. So this square will cancel this square root, and then we'll end up getting c being equal to root of what? A squared plus what? B squared. Okay, so having that, this is actually what we need to use in order to find the value of the p, in order to find the value of p. Okay, so quickly, without wasting time, we are going to go ahead to find the value of p by basically fixing in the values we already know. We know that a should be how do you call it? A should be 5. Okay, it doesn't matter because it's addition, so it doesn't matter if you mix it up. And then b should be root of what? 125. Okay, good. So wherever we see a, we are going to fix 5. Wherever we see b, we are going to fix root of 125. Okay, so let's go ahead quickly to do that. So doing that, we'll have this. So we'll have 5 squared plus what? Into bracket root of what? 125 squared. Okay, so some of you are actually worried about the square root. Okay, the square root of 125, the 125 being squared. The good thing is that because of the formula we are using, the formula gives us the square, so we can use that square to cancel the square root. So this square will cancel the square root. So at the end of the day, we should be having this root of 5 squared plus what? 125. Okay, root of 5 squared plus 125. And then basically when we continue solving, this should give us 25 plus 125. Okay, and that will end up giving us 150. So C basically is root of 150 centimeters, root of 150 centimeters. sorry, P. So C is the same as P technically because of where P is. It's on the hypotenuse, which is the slopey part of the triangle. Okay, so if you found C, it basically is the same as finding P. If you also want, you can actually interchange C with P and then you solve. Okay, if you also want, you can actually interchange C with P and then you solve. But if you don't, when you are done, you should state that C equals P. Therefore, P equals 1 to root of what? 150. Okay, root of 150. Let me clean this. And then remember, we are dealing with measurements, so you should have your measurements there. You should have your measurements there. Okay, so basically this is how to solve it. There was another question attached to this one which says that you should find area. So assuming you've been asked to find the area of this particular figure. Okay, remember, to find area of this particular figure, one should know the area for this rectangle, for this triangle. Okay, you can actually, so let's do that together. So I'll just clean this side of the board and I'm going to draw the three triangles that actually make up this shape technically, and then we are going to use it to find the area. Remember that the question, when it's we started a question, it didn't have this thing. Okay, so let me clean that. So if you've been asked to find the area, then basically it's going to mean that it's going to be only the way the shape looks like. That's how the area we are supposed to find the area. The way the shape looks like, that's how we are supposed to find the area. So let's work on finding the area of this shape. So I'll try and see if I can draw the same thing on the board. Okay, yes, I got it. So, and then we have this thing going this way. Okay. It's not straight, but I think we can manage. So we have this side. Okay. And then let me see if I can do the labelings quickly. So we have 10 centimeters. We have root of what? 125 centimeters. We have 5 centimeters. We established that this place is also 5 centimeters because of the distance that's supposed to be. Because this is 15 centimeters. P was root of 150. So we can put that there, root of what? 150. And then we have this place being root of what? 125 centimeters. Okay, so the markings or the drawing with the yellow is the area we are supposed to find. The broken lines are actually extra things to help us find the area. So when we take it this whole thing into consideration, including the broken lines, we get a rectangle. Okay, and then the formula for finding the area of a rectangle basically is just the length times what? The breadth or the width. And then the length, basically we can take it to be 10, and then we can take the width to be what? 1, root of 125. And then when we solve that, we should be able to get our answer. Okay, it's basically 10 root what? 125. Okay, 10 root 125. So once we have that, we've established that centimeter square. No, centimeter square. Okay, once we've established that that is the area, the next thing we need to do is to find the area of this triangle, and then we'll subtract it from what? The rectangle, in order to get what? It's basically like having a box and cutting the side off. That is what is going to give us the row shape, this shape that they are saying we should find. Okay, so I'm going to leave that aspect to you. We are going to try that aspect, and then you should let me know. Now, please, before we move to the next thing, or the next question, please take note that your assignment is obviously going to be attached to the description of the video before the video ends. It's not there now, but it will be posted there soon or before the video ends. The assignments are actually similar to what we are doing. This is just to help you reinforce what exactly I'm teaching. Okay, so please if you run to any situation, the assignment actually is not objectives. It is not an objective assignment, it's subjective. You are supposed to solve, take a picture of it, and send it to take a picture of it and upload it to Google Forms, just like the way we've been doing our last 2 or 3 assignments, the mock assignments. Okay, so you quickly do that and then you let me have it so that I can mark for you. But today is going to be an interesting day because we have interesting diagrams. You need to look at how to solve them. So without wasting time, we're going to move to the next one. And then the next one is actually also a diagram, but it is a diagram about a plane geometry, or is a plane geometry diagram. Okay, so let me move this to this side of the board a bit. So when you look at this closely, okay, someone will say this looks a bit scary, but it is not. I think most of you have seen this kind of questions in your textbooks, but you've not really paid attention to it. I really think you should pay attention to it, basically because if nothing at all, you've seen it in your textbooks, so you not paying attention to it would actually it will be painful if the same kind of question is presented to you, just like the way those who wrote their BECE in I think 2017 or so, they had the diagram of the fish behind their jotter. They never paid attention to it, and then thinking that they've actually taken the topic on fishery from the science syllabus, it was brought and then they found themselves wanting. Okay, so please, let's pay attention to anything we see in the textbooks, especially if it looks a bit complex. We should pay attention to it. Remember, the examiners also have access to those kind of textbooks. Okay? Good. So with this diagram quickly, I want to explain something. Now, when you have something like this, these 2 lines will never meet. Okay, these 2 lines, this one, let me change the marker. These 2 lines will never meet. Okay, hence the arrowhead, okay, which indicates that they will never meet. Good. Now, because they will never meet, and then the direction in which they are passing through, it gives us the license to draw a line through this middle part. Okay, so we can actually draw a straight line. My line might not be straight, but please pardon me. So we can actually draw a line through the straight line. Okay, so we can draw a line from the vertices of where the R is through it, and that is actually going to divide the R into some angles. Okay, so once we've done that, we can also conveniently put the arrowheads because they are all moving in the same direction and they can never meet. Okay, so that's the first thing we need to do. Once that is out of the way, we can go ahead to do some analysis, and our analysis is basically going to be concentrated on this kind of questions. So with this one, we've actually played around it a lot. So we can see that this angle and this angle is what? Corresponding. We can see that this angle and this angle is what? Vertically opposite. We can see this angle and this angle is what? Co-interior angles. And then we can also see that this angle and then this angle are alternating angles. So once we've done that, we want to look at this closely. Okay, we want to look at this closely and see this angle, a part of R. Okay, one part of R. Let me take a marker that I can use to indicate one part of R, which is this one. Okay, which is this angle, will be alternating with this angle. Okay, and then another part of R, which is this angle, will be alternating with what? This angle. Why will it be alternating with this angle? If I should trace this forms a Z shape, right? So the angle here will be equal to the angle there. If I should trace this also, this forms a Z shape, right? So the angle here will be equal to the angle there. Okay, so in a nutshell, one part of what? The R, we've actually gotten the answer to it, which is 32, and then the other part, we just have to look for the supplementary angle to 116 in order to get the other part of R, and then we'll sum it up to get the value of our R. Okay, so we'll sum it up to get the value of our R. So let me clean that, and then let me clean this. We are going to draw our very own from this diagram, anytime you are going to do a change to a diagram in a math question, we advise you redraw that diagram so that when you do the change, the examiner will know that you've actually done some kind of change to the diagram. So let me just choose this and let me see if I can use it to draw. So I'm trying to draw the thing again. Pardon me if it's not that straight, okay? Just manage. And then, okay, so I think we are good to go. Let me just put with the marker, let me just put the arrowheads here. And then this is R. Okay, let me make R very big because we need the space. So this is R. Okay, so let me just put the measurements. So this is 116. And this is 32. Okay, 116 and 32, and this is R. And I said because of the arrowheads, we can confidently draw a line to pass through. Can draw a line to pass through R. Okay, so that's the line I've actually drawn to pass through R. So once we've drawn that line to pass through R, remember that line will also have an arrowhead. So this is R, and this is also, the whole thing here is R. So we can quickly say that what? R should be equal to A plus what? B, which means that we can confidently name this side A and then this side what? B. Okay? And then we've established that. Let me write the 116 well so that everyone can see. Okay? So 1, 1. Oh, you can't see it's too small. So I'm actually trying to draw it again, so don't worry about it. Let me know if you still run into any challenge. So this is basically how the figure is, and then this side, the A plus B is actually the whole thing for R, okay? So A plus B, because of the line that is running through, it's actually the whole figure for R. Then, let me remove this. Good. So once we've established that, we can go ahead and use what the theories or the concept I already explained, or I just explained, okay? That this angle will be alternating with what? A. And then this angle will be alternating with what? 32. So we'll start by solving B first because B has actually been given to us. So we can say B and 32 are alternating angles, therefore B equals 32 degrees. So we found B. So it means that we can write 32 degrees over here. Okay? We can write 32 degrees over here. Then we can go ahead to find what? A. But before we find A, we need to find a supplementary angle for this. Okay? Because this is the angle we need to find what? A. Okay? This is the angle we need to find A. And that angle is supplementary with what? 116. Okay? So what it means is that supplementary angles add up to give us 180 degrees. Okay? So we are just going to do some form of addition. So it basically means that to find, let's do the supplementary angles first. Okay? So you can actually name this angle as what? X. So x plus 116 equals what? 180 degrees. So quickly say 180 degrees minus 116 equals x. Then we can say that what will be the answer? In the chat section, what do you think will be the answer? Okay, yes, so it has been provided 64 degrees. So we have B to be 64 degrees. So we have X to be 64 degrees. So let me write here 64 degrees. Now when X is 64 degrees, because we have what we call alternating angles, X is alternating with A. So A is also going to be what? 64. So 64. Okay, so once we have that, we have B to be what? 32, and then we've also solved for A to be what? 64 degrees. What do you think will be the value of what? R, angle R. In the chat section, what do you think will be the value of angle R? Quickly. Oh, the answer is not coming. 96. Awesome. Thank you very much, Elon. 96 degrees. Okay. So 96 degrees. So basically, the value of R is 96 degrees. It might seem a bit confusing at first, but just digest it. Take your time. If you can come back and watch the video over and over again. I don't know how long it takes for YouTube to upload the video, but once you join the streaming, you should have access to it, even if it has not been uploaded by YouTube on time. Okay, so basically this is how to find the value of R. And then anytime you have anything like this, don't be scared. You can actually do it using the same principle. So even if I should draw something like this, let me see if I can do a sample drawing. If I have something like this, okay, once I have this arrowheads here, if they say I should find this side, and they give me this side to be 70, and this place is X, and then they've actually placed an angle here, maybe 96, and then this place is what? 41. Okay, and they are saying I should find X. It's the same principle. Once you have these two lines not meeting because of the arrowheads, in case that they are what? Perpendicular, sorry, parallel, what it means is that you need to just basically draw the angle through this vertex. Okay, draw a line through this vertex, and then you can use that principle to find whatever you want. So this kind of questions are actually easy, but first time look makes it very difficult to digest. Let's move to the next example, and then this example is also an angle question. So for the sake of those who can't see, I'll try as much as possible to enlarge it. Let me know if the enlargement is okay for you, but it means that it limits our board space. But don't worry, I can just scroll down and then ensure that we have access to all that is on my screen at home. Okay, so basically this is what we have. This is what we have, and then they are saying we should find the value of K. Don't be scared. Don't be scared. We are going to do it together. Okay, we are going to do this together, so don't be scared. So to find the value of K, basically, the same principle applies. This arrowhead indicates that this line was from somewhere and it is going somewhere and it is never ending. If I should extend it to keep going, okay. So the fact that the line was stopped here doesn't mean that it can't be extended. So because it was from a point, okay, and they didn't say that that was the end of the point, okay. So this line can actually be extended. Let me clean this and then use a better representation. Okay, but I think you get the concept. I think you get the concept. So this line can be extended this way. It's not straight, but it's actually a line. So once it's extended, what do you think we have? We have a triangle now. Okay, we have a triangle now. This line can also be extended because it's from somewhere. Now, because we are extending, if I should redraw this, remember redrawing it basically means I'll have something like this. Okay, if I should redraw it, and then this side has been, it's this side taking into consideration. Let me change the marker. Taking into consideration this side, just this side of the, just this side should give you an indication that you should be working with something like this. Okay, so if you're working with something like this and this angle has been named, okay, so it looks like this. Okay, and this angle has been named. Would this angle be the same as the angle here? Okay, this angle will be the same as the angle here. Okay, and then this one too has been given. Okay, so if you have this, you have this. Can't you find this angle? Once you find this angle, is that angle not supplementary K in order to give it 180? So that's how you build the concept. Okay, so I'm going to clean this and then we are going to solve it very well. Okay, together. So don't worry about it. You should be fine. So establishing that principle, basically, what it means is that, let me see if I can quickly use the mouse to redraw this. Okay, so I have my line. Okay, let me choose this. So I have this line here, then I have this line here, okay, and then I have this line going this way, and then I have this line going here. So technically, after drawing the broken lines, that is how the diagram is going to look like. Okay, so technically, after drawing your broken lines, that's how your diagram is going to look like. So let's fix in the values. So fixing in the values, it means that this one is going to be 80 degrees. This is going to be K because that's what we are looking for. This is going to be 41, and then we don't know the side. Okay, so the size that you need to find, remember, if you have to label, you need to label. So I'm going to label this place as X, and then later I'll be using the side of the triangle. So I'm going to label this also as what? Y. Okay, because we'll be using it. So when you have a question like this and you need to do this kind of changes, your solution, you should have a new diagram that represents the changes you've done, so that the examiner can also pick those ones up and then. Oh, okay, sorry about that. Some people are complaining that they can't see the red marker. Sorry about that. Let me see. Will I have to draw the whole thing again? Okay, let me just, I know what to do. I hope it's better now. So basically, that is how. So let me know if it is okay. So basically, that is how you depict the drawing. Okay. So now let's just spring into action and go and solve. Now from our analysis, because of the arrowheads, we can say that 80 degrees is under the line, and then that line has a parallel line that has an angle under it. So they should be corresponding angles, right? They should be corresponding angles. So we can state that X and 80 degrees are corresponding angles. Therefore, X equals 80 degrees. So if X is equal to 80 degrees, then it means this side of the triangle we have here is 80 degrees. Okay. So, and then we already know that the total or the sum of angles in a triangle is equal to 180 degrees. So we can confidently say that to find y plus 80 degrees plus 41 degrees equal 180 degrees. Remember, now we are looking for the angle in this triangle. That's what is going to help us, because we need to find the value of y in order to find k, because y and k are supplementary angles. Okay, so having that, we need to do some form of addition. What will be the addition to the 80? What will be the addition to the 80 plus 41? That should give us 121. Okay, that should give us 121. I think without wasting time, I should be doing some of this calculations. But when I allow people to do it, it makes the thing interactive. So what will be the answer to that? What will be the answer to that? In the chat section, please, what will be the answer to? Awesome. So y now becomes what? 59. Okay. Y now becomes what? 59 degrees. So once we've established that y is 59 degrees, then we can go ahead to find k. We've established that y now is what? 59 degrees. Okay. So it means that 59 plus what? Sorry, let me clean this. 59 plus what? K should give us 180 degrees. So let me bring that calculation to the side of the board. So we have 59. Oh, come on. 59 degrees plus what? K equals 180 degrees. Why? Because K and 59 are supplementary angles. So from the look of things, who can tell me the value of K even without solving? What will be the value of K? Good. So the value of K, you realize, is actually the same as adding these two angles. Okay. So that brings us to another concept in plane geometry I want us to talk about quickly. Oh, why did I write 1, 2, 1? Because I was talking about the answers. That's interesting. So that's what, 59. Okay, as you all said, is 121 degrees. Okay, so when you realize that, as I've indicated in the 80 plus 40, remember, actually gives us the value of K. So if I should pick my mouse and then I draw this beautiful shape, let me see if I can add a line to it. Okay, if I have, let me just use this opportunity to explain this concept and then we'll move to the next example. Okay, if I have A and then I have B, okay, when I sum A and B up, it should give me X. And the principle is what? The sum of interior angle of a triangle is equal to its opposite exterior angle. So this interior angle, these two interior angles have an opposite exterior angle. They actually have an opposite interior angle, which will be this angle, but that's not what we look for, and that's not what we use for the principle. So it's actually equal to its opposite exterior angle, which is this X. Okay, now when you look at this diagram closely, it's basically the same diagram that has been flipped upside down. Okay, so if I should do the drawing of the diagram somewhere else, it basically means that let me see, can I do the flipping? Yeah, I think so. Oh, doesn't give me the chance to. No, I can do it. Okay, so rotate. So I'm trying to flip it so that it will actually depict. Okay, so awesome. So it basically looks like the same thing. Let me just put the line here. So why am I trying to make this justification? I'm trying to make this justification because if you know this, then we don't have to go through all this process by going to find y before we actually get the value of K. So we have K here, and then you realize that we'll have what, 80 degrees over here, and then we have 41 degrees over here. So you see, these are actually interior angles. When we sum these two interior angles, they'll be equal to the opposite exterior angle. That's how come when we solved for K, we ended up getting this. Okay, and that is also the same as the sum of these angles. Okay, so thank you very much, and then let's move to the next question, or the next thing we need to talk about, and that is actually this beautiful diagram you see on your screen. This diagram you see on your screen. But before we continue, please, if you're a first timer to this channel, can you subscribe to the channel? I know I have students who have not subscribed to my channel, and that is not being fair to me, and not being fair to me, because a lot goes in to produce this video. So the least you could do is to subscribe to the channel, or even give a thumbs up. Okay, like the video. We have about 21 students watching, or 21 people watching. So at least if I can get a replica or equivalent of 21 likes, it won't be that bad. Anyway, so this is the shape, and they are saying that we should find the perimeter of this shape. Perimeter basically means that if Kofi Kojo is standing here and Kofi Kojo decides to go around the thing, go around this shape, Kofi Kojo will pass here and then come and pass here and then we'll pass this way. And then we'll come and pass here. So that's perimeter. Perimeter basically means what? The distance around a shape or an object. Okay. So basically that is the perimeter concept. So they are saying that we should find the perimeter for this particular shape. Okay. Perimeter for this particular shape. Now when we look at it closely, we have a semicircle, right? So the first part, this is the first aspect of the semicircle. Okay, so we have to find that semicircle. Okay, we have to find that semicircle, and then this is another aspect of another semicircle. So let me indicate it. So we actually have two semicircles, this one and this one. So I can say semicircle A and then semicircle B. And then we have this distance that Kofi Kojo needs to also walk through. So distance 5 and then distance 5. So when we find this side, we need to find the one that will be inside that he has to walk through. And then we also need to add this because he passed the 5 centimeters and the 5 centimeters. So in a nutshell, we'll be adding 4 different measurements in order to get our answer correct. But before we add those 4 measurements, we need to find or do the calculations for the semicircle. And then the perimeter for a semicircle basically is the same as what? The circumference of a semicircle. And how do we get the circumference of a semicircle? Circumference of a semicircle is basically half the circumference of a circle. Okay? So to simplify this formula, basically, anything multiplied by 1 is that same thing. So this actually looks like this. Okay, all over 2, and this is the same as 2 pi r. So we write 2 pi r over 2. And since all these are multiplying, we can confidently cancel. So now we can say that the circumference of the perimeter of a semicircle is pi r. Okay, the half has actually taken the 2 off. Okay, so once we cancel it is what? Pi r. So once we've established that there's the formula for finding the circumference of the perimeter of a semicircle is pi r, then we can actually pick it and then use it to solve our question. So the first one we want to look at will be for the A, which is the bigger circumference or the biggest perimeter. So in order to do that, it basically means that we will end up having, let me do CA, which says that circumference of what? A is going to be pi r. Okay, and then they are saying that we should take pi to be 22 over 7. But before we do that, we need the radius. We need radius. So let's analyze the shape quickly. Now, from this side to this side gives us 10. So it means the middle, this place will be what? 5 centimeters, and this place will also be 5 centimeters. Okay, so the middle of this shape to this point is going to be the radius of the bigger circle, which forms the bigger circumference. Okay, so the radius is actually 10 for the bigger circumference. Okay, so 10, so we can say where r equals 10 centimeters. Okay, so we can actually fix that. So we have what? 22 over 7 times what? 10. And then we'll have 220 over 10. So solving that, what will be the answer? Long division quickly. Come on, people. Long division. 220 divided by 7. 220 divided by 7. Quickly, let's do that. Long division. So when you are done, just fix the answer in the chat section for us. So it means that our first, let me see if I can do this quickly. Okay, so we have 30. Someone has actually answered 31.4. I don't think the answer 4. 31.4, blah, 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 blah. Okay, so thank you very much, Manuel. So the first circumference, which is circumference A, is 31.4. Remember, circumference is just a measurement. It's not an area, so we will just write centimeters, not centimeter square. So we've actually found for the first circumference. So we are going to move to the next circumference, which will be circumference B, which will also take the same measurement, but the radius is going to be different. Okay, the radius is going to be different. So let me clean this. Oh, don't do that. So let me get rid of this, and then we are going to analyze. So when you look at it, this is actually the circumference, and it's a semicircle. Okay, and then from one side of the circumference to the other side of the circumference, passing through the center, gives us 10 centimeters, and this 10 centimeters basically is the diameter, and half of the diameter gives us the radius. So half of 10 is going to give us what? 5. Okay, so it basically means that our radius here is going to be what? 5 centimeters for the smaller one, which is circumference B. Okay, for the smaller one, which is circumference B. So that's what our radius is going to be. Okay, so we'll quickly fix that. So 22 over 7 times what? Someone should actually give us the final answer to this. 22 times 5, what will be the answer? 22 times 5, what will be the answer? Come on, guys. This is a live section. Let's make it live. Are you there? What will be the answer to 22? Okay, so 110. Thank you very much, Farah. Awesome. So we'll have that divided by what? 7. And then when we divide it by 7, what will be the final answer? So the final answer here, someone has answered 15.71. And then remember it's perimeter, so we'll have centimeters, not centimeter square. So we've actually found the answer to the second circumference. And then remember that Kofi Kote is not only going to work on the circumference A and B, and then you would have worked on all the perimeters, but he's also going to work on this side, which is not part of the circumference, and also going to work on this side, which is not part of the circumference. Okay, and that those sides are 5, 5. Okay, so it basically means that at the end of the day, the perimeter that we'll be finding should be the AC plus what? CA, which is circumference A, plus circumference B, plus the two lengths. So the two lengths, we can say 2, let me make it 2x. So this one represents x, and this one also represents what? X. Okay, so having that, we'll end up having 1 point. So please start doing the additions. Okay, start doing the additions, and then we'll have 15.71, and then plus what? 2 into bracket 5. Since they are all 5, but you know sometimes they can give you a different measurement for both. I wonder if that's possible. Yes, it's possible. They can give you different measurements for both. So what you can do is that just take note of it. You know how to multiply by 2. You can actually do simple additions for that. Okay, so you can actually do 5 plus 5, but I decided to do 2x, which is the same as what? So because 2 times 5 is 10, and then 5 plus 5 is 10, so it's basically the same. So let's quickly do the additions for that. What was the answer, or what will be the answer for the total perimeter? This gives us 10. So let me do one. Let me write it down for the sake of showing work. So what will be the answer? 50. Okay, so someone has actually produced the answer, which is what? 57.1 centimeters. So 57.1 centimeters, not centimeters square. Okay, so the perimeter for this particular shape is 57.1 centimeters. Okay, why 57.1? Remember, Kofi Kojo will come and work on this side. Okay, Kofi Kojo will work on this side, and then Kofi Kojo will also work on this side. We will not only work on the round part, which is the circumference of what? Each of the A and B that I have indicated them. Okay, so that brings us to the end of this particular question. Okay, please take note. As I said, they are similar to what you are supposed to do as the assignment, so please take note. Which, if any case or if something should happen that you get confused, all you need to do is to just come back to watch the video and then you should be sorted out. I don't expect anyone to get below 100. I've actually scored it over 100, so I don't expect anyone to get below 100 because they are the same things that are presented. The figures are not the same anyway, but the diagrams are the same. Okay, so I've just changed the figures for that particular one. Okay, so how do you have to turn in your assignment? Solve it on a paper. Please, when you solve it on a paper, write your name. Those who will not write their name, I can actually do that. Because I don't know your handwriting, I can't judge if you actually took the question or the solution from someone. So ensure that your name is on the paper, the page that you are taking the picture of, and then you present that. Okay, so having that, let's look at this. Now they are saying that we should find the value of h. They are saying that we should find the value of h. This is the easiest way this question can be put. Okay, they can actually say that since this is if they want to make it complicated, since this is the center and then from the center to the circumference gives us radius, they can actually put x here and then give you this as 6 centimeters. Okay, and then they'll say find the value of x or find the radius of the circle. That's the complex aspect this question can get to, and then we'll be looking at that. Okay, we'll be looking at that, how to solve something like that when they give it to you. But first of all, let's just concentrate on how to solve this. And then how to solve this, basically, if you are with me at the beginning of the lesson, you shouldn't be worried. This actually makes a perpendicular line. This is actually a perpendicular line, so which means this is what, 90 degrees. Once you have 90 degrees in a triangle, then it basically means you are dealing with what? A right-angled triangle. A right-angled triangle. And when you're dealing with a right-angled triangle, it becomes easy to find the sides, it becomes easy to find the area and all that because you would have the height. Okay, so quickly, and then also this particular question, they can actually decide to shade this side. And then they'll say find the area of the unshaded region. Okay, so all this can actually be done. So we'll look at all those three concepts before we call it, or we move to the next example. Okay, we'll look at all those three concepts before we move to the next example. So without wasting time, let's just solve this one, and then I'll redraw the other ones, and then we'll solve them so that we can actually be solid in whatever we are doing. So quickly, the first thing is, since they are saying we should find this, and then this height does not extend all the way to touch this side. If it was extending all the way to touch this side, then it would have been the same as the radius. Okay, so luckily enough, they didn't say that because it would have been confusing a bit. Okay, so all we need to do is to just pick out the diagram and redraw. So that is it. Then I'm going to label this place is h, this place is 6 centimeters, and this place is 5 centimeters. Okay, so from Pythagoras theorem, we have that c squared a squared, let me write this, oh, it looks horrible, and then b squared. Okay, the formula actually is c squared equals a squared plus what, b squared. By now you should be bored with this formula because I actually explained it in the first example. Okay, but it's very, very important. I'll keep hammering this so they get in. This actually, I don't think we've done it in school for Richard School students, but so you should pay much attention to it. Everyone should actually pay much attention to it, because one thing about that particular topic is that they can bring it in different forms, and you don't know, if you don't pay attention and you don't get so soaked into it, you might not know that that is what they want you to do. So yes, to continue, basically, once we've written this formula down, we are going to use this formula to find h. And then when you look at this closely and compare, we'll see that h will be the same as what, b over here. Okay, so if you are able to find b, then it means we are finding h. So to use the same thing, we can say that 6 squared equal, because the c represents the 6, equal 5 squared plus what? H squared. Remember, we are looking for h, not h squared. So at some point, we would have to get rid of the square. Okay. So to solve this, this will be 6 squared minus 5 squared equals what? H. Stop misbehaving. H squared. Okay. So this will be 36 minus what? 25. What will be the answer quickly? 36 minus 25. Okay. So once we have that, we can. No, it's not. It's not one. It's one. Yeah. No. Yeah. No. Yeah. So basically, once we have that, we can go ahead and then it's not 9. 11. So once we have that, we can basically go ahead and then okay, yeah. So we can go ahead and then find h by getting rid of the square by applying square root on both sides. So this square root will cancel this, and then we'll have h to be equal to, today is like I'm bombarding you with a lot of square roots, right? Yeah, it should be yeah, Ronnie, thank you very much. Root of 11 is h. So that is it. So root of 11 is h, but please don't forget that if the fact that it is roots doesn't mean it should be, you should ignore the units. Okay, so you bring it since the thing has been in centimeters. So that is the easy part of it. Now let's look at the complex parts and how they can actually pose questions like that to us. So I'm going to clean that side of the board and I'm going to do the drawings for those two concepts. Once I'm done with those drawings, then we can solve them together. Okay, so please be on the lookout because I'm just basically going to guide you to do it. Okay, so let me see. Okay. This might not be exact, so just bear with me. Come on. Just extend it. Okay, so and then we have, let me see if I can just use my hand to draw that. Awesome. So that's it. So we have this, okay? And then they are saying that, or they said we should find, they didn't even say anything. They just gave us this to be maybe, let me see, let me put 13 here, 13 centimeters. And then they gave us this to be 4 centimeters. And then they stated that find the radius. Find the radius of the circle. Okay, so something like this has been given to you. What would you do? Now, as I explained, when you look at this closely, because this line is coming from the center and is touching the circumference, that's actually the definition for radius, right? That's actually the definition for radius. So if it's the definition for the radius, then it basically means that when we find that side of the triangle, we should be able to find the radius and then state it as the radius. So if we should pick that side of the right angle triangle out, then it means this side is what? C. This will be a square and then this will be b square. I'm not going to go into details on how to solve it. From what we've done so far, it basically means that all you need to do is to find the value of c. Okay, that's what it means. It basically means that all you need to do is to find the value of c. So you go ahead and then you find the value of what? C. And then when you find the value of c, that is going to be the answer to the radius of the circle. Okay, why would that be the answer to the radius of the circle? Because the line, which is this slope, which is called hypotenuse in Pythagoras theorem, starts from the center and touches the circumference. Okay, so that is the definition for radius. But what if What if the only thing that was given to you, they said you should find the area, and then the only thing that was given, the area for the unshaded region. So it means all the side that has not been shaded. It basically means we need to find the area for the triangle, and then we'll subtract it from the area of what? The circle. So which means that to find the area of the circle, we need a radius. So it means you have to find the radius. When you are done, you have to use these two labels to find the area of the right angle triangle, and then you subtract it from the area of the circle. So let's quickly do that. So we are going to find the area, the radius of the circle by finding c. So let's establish the formula, which is going to be c squared plus a squared plus what? B squared. So you can be doing it quickly so that we can finish it. So this will be c root of, let me just use a shortcut, root of what? A squared plus what? B squared. And then we can say root of what? 4 squared plus what? 13 squared. And then 4 squared will give us 16 plus what? 169. I hope I'm correct. Check quickly. So what will be the answer? What will be the answer? In the chat section, what will be the answer? So let's add 16 plus okay, so root of 185. So c is equal to root of what? 185. Is that correct? Root of 185. So we can say centimeters. Okay, we can say centimeters. So once we found the how do you call it, the radius, which is root of 185. Is root of 185 a perfect square? Is there any two numbers that will multiply to give us 185? I don't think so. So we can state that root of what? 185. Okay, so we have root of 185 as our radius. Now we are going to use that root of 185 to find the area. And then remember, area of the circle is what? Pi r squared. Okay, they didn't give us pi because that was not the point, but we can say take pi to be 22/7. Okay, so it basically means that let me clean this. 22/7 times what? Into bracket root of what? 185 square. So now you realize that the square will easily cancel the square root for us. At the end of the day, we'll end up getting 22/7. Please do the calculations for us quickly. Times what? 185. Okay, can 7 go into 185? If it can't, quickly just multiply 22 times 185 and divide it by 7. What will be the answer? Interactive class, guys. What will be the answer? So what will be the answer to that? Or I should go ahead. Okay, let me just go ahead and state it. Okay, so it has been stated for me by William. William, let me know you. Do I know William? So 581.4 centimeter square. Okay, 581.4 centimeter square. So basically that is a good thing. 581.4 centimeter square. So that is the area for the circle. Now let's quickly move and find the area of this triangle. Okay, right angle triangle. So let me remove these things because we don't need it. So I can just use it to find the area. What's the formula for finding the area of a triangle? It is half base times height. So when we look at this closely, we have our base to be 4 centimeters, and then we have our height, because it is perpendicular, we have our height. We'll take that one as our height to be 13. So it becomes what? Half of what? Let me write the formula, okay? No shortcuts. Right. So times what? 13. This 2 cancel to give us 2. So it becomes 1 times 2 times what? 13. And that's going to be 2 times what? 13. And then this will give us 26. So 26 centimeters square. So you are just supposed to just do the subtraction for that. So the area for the unshaded region will actually be the subtraction of what? 581.4 centimeters minus 26. And what will be the answer? So thank you very much, Rodney. 5.4. Please, if anyone states the answer, even if I write the answer, please verify to ensure that it is correct so that we can all be on the same page. So yeah, okay, so Elon to has sent the same answer, so it means it's correct. So 555.4 centimeter square is the area for the unshaded region. Okay, the area for, if I should clean all these measurements, you see the unshaded region. Okay. So the unshaded region is actually the region in black. So this one is also part of it. Let's just assume that this line is not there. Let me see if I can read the line. Okay, so basically this is the unshaded region, just around it like this. And I think last week we looked at a question that also had that kind of thing, but it wasn't a triangle that was in it. It was a circle, a smaller circle in a circle. Okay, because a smaller circle in a circle. So that is good. As I said, William, let me know you. Your last name doesn't show that I really know you. Okay, so we have this beautiful one, which is our next example. Let's see. Awesome. So please subscribe to the channel. I should be sleeping by now, but I'm teaching. Oh God, thank you very much. Okay, so what is the value of n? What is the value of n? This is actually an indices question, or what some people will say powers of numbers question. Index, the plural form is indices. Okay, index, the plural form is indices. So if I should write this in an index form, okay, but if I have several of them, then this becomes an indices. Okay, then this becomes an indices. So let's quickly dive deep into this and see how best we can solve this. We'll see how best we can solve this. Okay, so to solve this, we are going to look at some rules surrounding this, and those rules are going to help us solve this. Now, when you look at this closely, this might be scary at the first time, but you shouldn't be worried about it. So I'm going to guide you through it so that you can solve it. So we are going to look at some rules that we'll be applying. Then the basic rule is that ensure that everything, all the base numbers are the same. Then your life will be easier when you are solving any equation involving what? Indices. Okay. So what will be our base number? We have 3. So let's check. And we have 9. And then we have what? 81. Now 3 is the smallest number here. So we are going to find out if 3 multiplying itself can give us 9 and then can give us what? 81. So let's check. Maybe 3 multiplying itself will give us 9. So this is 3 times 3, right? And then this one will be 3 times what? 3 times what? 3 times what? 3. So it means what? 3 is the power 4. Is that right? Is it 3 is the power 4? This will give us 9. This will give us 27. And then this will give us 81, right? Awesome. So basically it's 3 raised to the power 4. Okay. So once we've established that, it means that we can change all this to be 3, so that all the base numbers will be the same, and then we can solve it. Good. So then remember that bracket also means multiplication. So we'll be removing the bracket and then we'll be bringing multiplication, yes, to also apply a certain rule in what? Indices. So with this one, we're going to be applying a lot of rules, okay? The first rule I want us to apply to make our life easy. If you have not watched my video on indices, please, it's an extensive video on all the rules you ever need in indices. Please, when you are done with the class, just look for it and then familiarize yourself with those rules. I think it's about 6 or 7 rules. Once you have those rules at your fingertips, this question should be easy and straightforward for you to solve. So let's look at the first rule. I need to simplify this side of the question. Okay, so let me put a box around it to indicate that that's what I want to simplify. Okay, so I need to simplify this side of the question. Okay, so if I want to simplify this side of the question, there's a rule I need to apply. If I have A over B, and it's in a bracket and then it's being raised to the power x. It basically means that it can be a raised to the power x over what, b raised to the power x. I can use that rule, but I think I'll prefer using this rule, which says that if I have a 1 over a, okay, is the same as what, a raised to the power negative 1. I think I prefer using that rule, so I'll end up using that rule because that will make things easy. So if I should take what is in the box, which is into bracket 1 over 9 all raised to the power n. So what is it? Okay, let me write it. Oh no, wasn't. Sorry about that. Come back. Okay. So once I have established that this, then we'll have what is n, right? Good. So I'm going to change this. I'm going to change this 1 over 9 to look exactly like this one. So it becomes what, 9 raised to the power negative 1. And then remember the n, bracket means multiplication. So the n will be multiplying. So at the end of the day, we should have something like this, 9 raised to the power negative n. Okay? 9 raised to the power negative n. Are you now joining the class? Hey! 9 raised to the power negative n. Okay? So having that, we've established that we can now say that we have 3. Remember, bracket means multiplication. So 3 times what? 9 raised to the power negative n. Now let's simplify this side of the equation by changing it to what? 3 raised to the power 4. Remember, 3 raised to the power 4, we've already established that is the same as 81. So 3 raised to the power 4 into bracket n minus what? 1. So now it is equal to what? 3 raised to the power 4 into bracket n minus what? 1. Okay? So once you've established that, you realize that this one, we have this base number, but the 9 is still there. So we have to change the 9 so that we can get it to look like the other base number. So this becomes 3 times what? 3 times, we multiply 3 to give us 9. So it is what? 3 raised to the power 2 into bracket minus n. We'll simplify that part soon. So 3 raised to the power 4 into bracket n minus 1. Okay. So applying that to this basically will mean that we will have 3. The 3 is actually raised to the power 1, so we can write that. And then multiplying 3 raised to the power negative what? 2n. For that negative 2n is because I actually multiplied the negative n by the 2. Okay, and then we have 3 raised to the power 4 n. I'm expanding minus what? 4. It's not really necessary to do this part now, but I just decided to do it so that it will simplify things for me. So once I've established that, there's another rule that says that if I have a raised to the power b times what? A raised to the power c. Since the base numbers are the same, and then we have the operation sign as multiplication, all we need to do is to add the powers. So it's the same thing I'm going to be doing here. So it becomes 3 raised to the power 1 plus what? Into bracket negative 2n equals 3 raised to the power 4n minus 4. Sorry, I'm solving my math horizontally. You don't understand. Don't worry, I'll go over it. So it means that it's the rules that you're not familiar with. Okay, so please try as much as possible to get access to that tutorial. Let me see if I can paste the link in the let me see if I can paste the link quickly so that you can get access to it. But as I said, okay, I'm pasting the link right now so that you can get access to it after this class. Okay. So William, that's the link. It will give you details of the rules of indices, all the rules of indices. So later you can actually watch it. If you're also watching and you're a bit confused, it means you need to watch that particular lesson. Okay. There's also another one which is application of the rules of indices. I'll also add that link shortly. But let's go back. But maybe when I'm done, I would have to go over it again, and then those who are confused can get the understanding. So we've established this. Now that the base numbers are the same. Nathan, are you now joining us? Now that the base numbers are the same, you can just cancel the base numbers and then we'll derive what? A linear equation out of it. So we have 1 plus into bracket negative 2n equals 4n minus 4. Okay? So having that, all we need to do now is to do our linear equation and find the value of what? N. So to do that, we have 1 minus 2 equals 4n minus 4. Okay? And then we'll have into bracket 4n plus what? 2. And then we'll have 1 plus what? 4. Let me bring this here because of space, so I have to be solving this way. Please forgive me. Oh, okay. I thought you were now joining. Okay. Okay. So Rodney, till I ask for the answer, please don't post the answer, okay, so that you don't distract anyone. So we have 5 here, and then we have 6n. Okay. We divide both sides by what? 6, and then we cancel. So this will be 5 over 6 equals what? N. Okay. So n is actually, the value of n is actually 5 over 6. Okay, so those who are confused because of time and then because of other people on the platform, what I would plead you to do is that just come back and watch this aspect of the video over and over again and get understanding. Remember, we're looking at the different rules that we can use to simplify the 1 over 9 raised to the power n or raised to the power n. Okay, so that's where we build the point from, and then once we did that, we were able to establish that 1 over n can now be changed to what? This. So that's how come we have 9 raised to the power negative 1 into bracket n. Okay. So basically this is how, or this is the process you need to follow in order to get what? Your answer n. So please watch that tutorial if you are confused about the rules, and then also watch this aspect of the video which is going to help you solve this kind of question. Remember, a sample of this question is as part of your assignment. Okay, a sample of this question is part of your assignment, and then please pay attention and stop chatting. Okay, so you need to pay attention to this particular part, especially if you don't understand. It means you have to come and watch the video. Let's look at, I think this is the last thing we need to look at before we go, which is also a plain geometry question. I know most of you don't like plain geometry, but you should be able to manage. I hope the diagram is big and visible enough. Okay, I hope the diagram is big and visible enough. If you have any issue with the diagram, let me know so that I can actually see how best I can enlarge it for you. Okay, so yeah. So we are going to solve this. Now with this one too, it looks like the same thing we looked at the first time. Okay, just that it has been slanted in a way that looks a bit scary. So we can confidently say that this does it. And then they are actually saying that we should find y. Okay, because of the direction of the arrowheads, we can come to this vertex and then apply a line. Okay, once we apply a line, you realize that this angle is divided into 2 parts. It divides the angle into 2 equal parts for us. Let me put the arrowhead here. Okay, so once we have established that this forms a Z shape for us, okay, so it means this side will also be 72, and then this also forms a Z shape for us, so it means this side will also be Y. Okay, so if I have 208 plus 72 plus y, okay, it should be equal to what? 360, because it should be equal to 360 basically because this is what? A circle. Okay, so what I mean is that if, let me just plant this way, and then we have 208. We have this place to be 72, we have this place to be y. So because of the arrowheads that have been given, we can just confidently draw another perpendicular line to go through it. Let me draw this thing. And that perpendicular line going through it will have a Z shape. It means that this place is equal to this place because it's alternating. And then we'll also have a Z shape here. So it means that this is equal to what? This. So here is y and here is 72. Okay. All this angle plus the 208 should sum up to give us 360. So at the end of the day, it's actually 208 plus what? 72 plus what? Y equals what? 360. Why 360? Because this side is what? 208. And then this side we don't know. So that side we've actually found, which is 72 plus y. So when we add it, all should be angle in a circle. So once it's an angle in a circle, then we should be able to find the value for it. Now what will be the calculation? This will be what? This will be 280, right? 280 degrees plus y equals 360. Please do the subtraction for us quickly. We are far behind time. Degrees, so y. So what will be the value of y? Quickly. The value of y is 80. Thank you very much, Rebecca and Rodney. The value of y is what? 80. So 80 degrees is the value of y. So anytime you have two lines being parallel in any of the plane geometry questions and you have something like this, it means that another parallel line can be drawn to pass through the vertex of that, and then once you do that, you should be able to get your answer. So I hope you understand. Before you go, please come back and comment on this video a topic you would want me to treat. Because next month I want us to take this thing topic by topic. No more questions, okay? We'll be taking topic by topic to help those who be writing BECE later this year. So if you're a BECE candidate and there's a particular topic that is bothering you, in the comment section, not in the live section, not in the live section. When the video is posted, maybe next day, come back and just comment on it, the topic you want me to treat. For Richard School students, you are supposed to comment on the video later that you actually watched the lesson, because it's not everyone that is here now. I know some of you will come back later to come and watch it. Okay, so you have to comment so that when I'm recording with the marks, I can actually record your attendance too in addition. Okay, so thank you very much for watching me for today. I'm really grateful. Please, if you are not a subscriber to the channel, kindly subscribe to the channel. Okay, kindly subscribe to the channel. Now with this particular thing we've done, I'm going to be slashing the questions into segments, and I'm going to be posting them as separate videos, so that if you want to watch a particular question or solutions to a particular question, you can quickly come and then select that question and then watch it. You know by the diagram, so the thumbnails will look like this, so it will indicate which particular one you are watching. Okay, so feel free, explore the channel. There are lots of tutorials on the channel. Some of you have not actually watched, so watch it and then actually improve your knowledge in math. Thank you very much and have a nice day. It was good teaching you today. See you on Tuesday, and then Tuesday, do not come and watch alone. Invite someone to come and watch with you, and let's all learn together. Bye bye. So I'm trying to post your assignments, and I want to enable the response so that you can actually access it. So I'm going to post the link to your description, okay, to the description of the video. shortly, so just stay tuned. And then quickly, if you want to start now, you can start now. But as I said, if you run into any issues, all you need to do is to come back and then watch the video. Do not try to be a hero and then fail. Okay? So basically, have a nice day and enjoy the rest of your day. Bye bye. The stream ends now. If you have any questions in the comment section, bye.